Welcome everyone to the day 4. In the day 4 today we're going to learn about variables and data type. What are variables in Java? What are the data types? What are the different data types which Java support? Let's try to understand each of them in a hands-on manner. Let's get started. So the next important concept that we need to understand is the variables and the data types. What is a variable? In very simple terms, if I have to explain you what a variable is, variables are nothing but the containers. Variables are nothing but a containers. You can assume variables more of like, let's say that there's a cupboard, right? And in the cupboards there are multiple sections, right? There are multiple different sections, right? And each section has a name. Let's say this section has a name A, this section has a name B, and this section has a name C. And this section A, which has a name, in this you can go and store all the liquid items. In the B you can go and store all the solid items. In this you can go and put the frozen items. So all these containers A, B and C, which has a name and which also have indication that what kind of items that it can hold, are called as, you can think of them as a variables. For example, inside the A, I can go and put items like I can go and put the fruity. I can go and put water because A can store and A can store the liquid items. Similarly, in the B, I can go and put something, for example, I go and put the book. I can go and put something called as pen because these are the solid items and B can store it. C, I can go and put something like ice. So a variable is something which can hold data, and specifically if I go and talk about the Java as a programming language, it's a statically typed programming language. Let me go and talk about what a statically typed programming language is. So normally, sir, if I go and talk about the world of the programming languages, there are two types of the programming language. One is called as strongly typed or statically typed, or something is called as a dynamically typed. A strongly typed language is a one in which when we go and define a variable, let's say that I go and define a variable called as x, I will also have to go and tell what type it is. It is gonna store integer, or it is gonna store string, or it is gonna store double. I have to go and define the type of it. On the other hand, dynamically typed programming languages are the one in which when you go and define a variable called as x, you don't have to go and tell what type it is. It will be interpreted at the runtime depending on what value it is storing itself. Now for the language at hand, which is Java, Java is a strongly typed variable. What that means that every time you go and define a variable in Java, you will have to go and define that what type it is. Now let's try to understand this in detail with the help of an example with a hands-on. Let's see Java variables in action. So what I do is that I'll go and create another class. Let me go and call it as class, and let me go and call it as learn variable. The name of the class should always start with a capital letter, and if let's say there are multiple words in the name, let's make it camel case. There should not be any space in the names of a class. So let me go and call it as a learn variable, and since I want this class to be executable, I want this class to have a method public static void main. So I go and include this public static void main inside this class and click on the finish. Fair enough. So as we discuss what is a variable, variable is something which can hold data. Let's say that I want to hold data called as 5. So if I go and do this x equals to 5 and semicolon, I still see that this Eclipse is throwing me an error. Okay, let me go and bring the Eclipse back. You see, this is throwing me a error, right? If I see here, this point is throwing me an error. If you want to see what the error is, you can just go and click on this and it will say that remove assignment. Fair enough. It is giving the error because we know that Java is a strongly typed programming language. So whenever you go and define a variable, you have to go and define the type. We'll talk about all the types later on, but let's say that it is a number, it's a numeric type. So we have to go and define the type here. So if I go and define int x equals to 5, now this error is gone. So this type of defining variable where I have said that I'm defining a variable called as x. So this x has a type, and the type is integer, and it also has a value. The value is equals to 5. So every variable that we go and define, boss, it has a type and it has a value. And secondly, since it is a variable, it means that it can vary. So right now it has a value as x equals to 5, but if we want to modify this, I can again go and say that, hey boss, x is equals to 7. So I can always go and reassign a value. As the name itself says, variable which varies. So a variable can go and store the another value inside it. So int x is equal to 5, I can go and say that x is equals to 7. Now x equals to 7 means that x is now holding 7, right? So anytime I go and need it, I can go and print it. So I can go and say that system dot out dot println, and if I go and do the x and print it, if I go and run this program, okay, if I go and save this and run this program, this will go and print 7. So whatever that I have written x is now actually representing the value 7. Fair enough. So two things. We know that any variable that we hold, their value can change. That's why I call it as variable. Second, it should have a data type and it should also hold a value. And then I can, using that variable, I can go and call that value again and again. Fair enough. Now, one more thing. If you see here in this example, here at this point, when I go and say that x is equals to 5, when I go and say that x is equals to 5 in this case, here I am declaring also. What is the declaring part? The declaring part is this, int equals to x, this is the declaration, and when I'm assigning the value, this typically is called as assigning the value. So when I go and say x is equal to 5, I'm trying to assign 5 to the x. Another when I can go and declare and define a variable is that, let's say that I go and define another variable called as int y. So here this point is only the declaration, I have only declared. Right. In the world of the Java, if I have to go and comment something so that the user can understand why this code was written, but I don't want Java compiler to go and compile and execute it, I do it with the help of this notation that you can see. I have already added a comment here, right? This is a comment we go and add in the Java. So I've defined y, and if you see here, as soon as I do it, there's some warning saying, if I go and click on this, right, if I go and click on this, it is saying that remove y on all assignment, remove y, keep assignment the side effect, convert local variable to the field, the different option that it is giving. It is giving because I have not assigned any value to the y. So what I can do now is that I can go and say that y equals to 24. So if you see here I have declared, and now here what I have done is that I have defined. So many of the times you first go and define a variable and then so it is defined, later on you go and, first you go and declare the variable, and when it is declared you go and finally go and define it. Fair enough, I have done this. Now let's say to do one more experiment here. Y is said that it is of data type int. What if I want to go and store in y another value? Let's say that I want to go and store y a name Vishwa. If I go and do this, again, not to my surprise, this will not work out. Why it will not work out? Because Java is smart enough to say that, dude, this value that you're going to store is of the type string. The y that you have is of type int, which does not match. So I will not allow you to store Vishwa. It is like going back to our example. I gave you an example of this, right? So if it is a box which can only store liquid item, if you want to go and store a solid item, what will happen? It will get spoiled. So that will not allow you to do it. Same thing is happening here. In this case, you are trying to store string in a data type variable of int, and it will not allow you do that. So this is how you go and define variables. You have to go and define the data types. We'll soon see what are the different types of data types in Java, both primitives and non-primitives. But for now, we have understood what variables are. Now, since we have understood what variables are, let's try to understand that what are the naming conventions that we need to follow to define the variables. What are the naming conventions that we need to follow to define the variables? Naming convention. So Java naming convention says that the variable name can only contain either small a to small z or capital A to capital Z or 0 to 9, or only two special characters, one is underscore and another one is $. These are the only characters which is allowed to you when you are naming a variable. That's number one. The second rule says that you cannot start a name with a numeric value 0 to 9. A number can't be used to start a variable. You cannot use a number 0 to 9 to go and start a variable. That's number two. Number third point that says that in the name, the variable name, there could be no blank spaces. You cannot have the blank spaces when you're defining the variable name. The number 4 says that in a variable name, there are fixed keywords. For example, when we move further, we'll see that there are concepts like if, for, while. There are multiple reserved keywords which have a special meaning in the world of the Java code. Java says that use any name, but please don't use these fixed keywords which is reserved in the Java world. So you cannot use reserved keywords. Again, you don't need to mug up all these keywords. As we make progress, we'll do enough practice so that it is in your mind and you will not mess using those reserved keywords. And last but not the least, it's a normal suggestion that you should try to keep your name smaller and meaningful. What that means that, let's say that if you have to go and store the age. So one of the ways that to store the age is that you go and store age as x equals to 5. Let's say that. Now when I look at x equals to 5, it does not give me any indication that what kind of data it is. A rather better name would be that if we have to go and store the age, let me go and store it to the age itself, right? I can go and say that age equals to 19. So when I go and see this variable name, I understand that what kind of data and why I am storing it. So this is how we go and define the variable. This is the convention that we normally go and follow. If you don't follow any of these conversions, you will find things that error out. Let's try to see that in the example. So if I go and see the Eclipse here, and let me go and define something called as 4-5 name equals to Vishwa. It will not allow me because it is starting with the letter. Let me also define the type just to ensure that it's not giving me an error. Let me go and comment this out. I'm still getting the error here. And what is the error here? You see here, even if everything is all fine, I'm having an error here like this. Right, I'm having the error here because the number is starting with the keyword 45. So now we have understood variable. Now let's try to move further and understand what are the different types of data types in Java. Now let's try to move on further. As we can see, this kind of variable name will not work out. Let's comment on. Let's try to customize this whole pane. I think to the left section you might not be able to see it clearly. So for doing that, if I want to increase the font size of the left section and this section, I think it's coming very small. I can go to the Eclipse, go to the settings, and I'll go and click on the font. Let me go and click on the fonts. And here in this case, I have to come to the view and the editor folders, right? Here when I go and come, I can go and customize what color it should look like. I want to go and change the font. Let me go and click on this. Let me go and increase the font and let's make it 18, which is here. Click on the apply. Right, this has become 1. And the tree and table font for the views, if I go and see here, let me also make this 18. Close this, click on the apply and apply in the close. As you can see here, the size got increased, right? And now I think it should be clearly visible to you people. As I said, you don't have to worry about knowing everything at the zero place itself. As we make the progress in the course, eventually, as and slowly, As and when the things are needed, we'll go and learn that, right? So this is how now it's showing clearly. This is also now clearly visible. Fair enough. Now, as we move on, the different types of the variables or the data types have certain operation associated with them. Say, for example, if I go and say that x is equals to 7, right? And in this case, if I scroll down and write something like this, so if I have to go and write system.out.println, so I can also write sys out, and when I go and do this control space, it will go and auto complete the system out.println. Just give it a try, and I think it was a very handy shortcut that you will need. Now if I go and put x plus 5 here, right, where plus is an operator, as you can see here, when I go and do x plus 5 and try to run this, let's try to see what happens. When I go and run this, let me go and save this. So initially x value was 7 and it was printing 7. When I go and add 5 to this, it has printed 12. So the plus operator has a special meaning to this data type x, which is of the type integer. On the other hand, let's say that I go and define another data type. For example, I have another data type called as string, and I go and call its name equals to Vishwa. Fair enough. I put a semicolon to close this. And now in this case, again, if I go and do that sys out, right, and I go and call it as name and the same icon plus, and let's say that I go and say that 7, and I save this file and try to run this. What it has done is that here in this case, here when I go and make use of plus, it has done the addition. Where I use the plus, it has just appended. If I use another icon, for example, on the other hand, if I go and make use of something like this, and I go and say name minus 7. Now it says that minus is not supported. If you see here, the minus is not supported. Not. So the point that I'm trying to tell you here, and you people should understand here, is that in the world of the Java, the different data types are different types of the operators that is going to support, and we'll see in details as we move forward. So now we have so far few things that I want you people to keep in mind, is that in the world of Java, right, when it comes about the execution, I know that the world of the Java, it comes about the execution. I know that everything has to be written inside a class. The name of the class should be in the capital letter. The name of the class should be same as the name of the Java file. If I want anything to be executed, it has to be written inside the public static void main method. We'll go and decipher that in detail in the coming time. And another thing is that everything has to be executed line by line. Variables are the containers for the data, which also has a data type. A variable with a designated data type can only store values of that nature. A different data type, values cannot be stored in the variable itself. So now since we have understood all these things, let's try to move on and talk about another thing which is called as data types. Let's talk about the different types of data types here. So let me go and define another file here, and let me call it as data types. Let me clean this up. Fair enough. And then since I have to execute it, I go and call it as public. I can type it myself if I don't go and select it while I'm defining the class. Public static void main string args. Fair enough. Cool. So the first data type that we have already seen, let's get started with the int itself, right? So let me go and define int number equals to 100, right? So I go and define a variable called as num, and its data type is 1000 or 10,000. Now, how big a value I can go and store in this variable called as num? Let's keep on increasing the value. Yes, it's not given error. Let's go and increase it. Let's keep on increasing. Let's keep on increasing. Let's keep on increasing. As soon as I do here, right, when I go and add this long number, it had started giving me the error, right? If you see here, this is the error out. It is trying to say that number type is integer, but you cannot go beyond this, right? Till the time I am here, it's all well. When I go to this last one additional 0 and it started giving me the compilation error. So with that, what we understand is every data type that is there in Java, it has a fixed size. You cannot go beyond that. There's a minimum of size that it will store and there's a maximum size it will go and store. Similarly, if I go and talk in the negative sense itself, let me go and define another number. Let me go and call it as int num2 and let me go and call it as 100, all well. Right, if I keep on adding 0, it's all fine, but when it go beyond a certain limit, here if you can see here, it is again giving me the error. So what we see is that every data, including number, has a definite data size. Now it's not very important to do for you to go and mug up, but just for your reference, typically in the case of int, a number can go and store up to maximum 2 to the power 31. Right? Beyond that, it's not going to store that. So what if I have to go and store a data which is bigger than this, which cannot be stored inside the int, where should I go and store it? So the next data type which could be used to store the very large numbers, that is called as the long. So what that means is, this I cannot go and store here, so I'll go and store a smaller value here. Right, so I'll just store the smaller value. Now if I have to go and store a larger value, I go and say that int, not int, I go and call it as long, and I go and call it as big num, and then if I go and see this number, if you see here, it is all fine. As you can see, I am going much bigger. Now here also it has started giving the error. Let's try to see that what is the error that is trying to do. Now when you go and run this, Java interpreter understand this is a very big number, but it is thinking that it is still int only, and that's why it is giving the error. So if I have to make them believe that okay, it's not an integer, it's a long number, I have to go and suffix it with the keyword called as L. What I'll have to do, I'll have to go and suffix it with the keyword called as the L. As soon as I do it, this is considered as a long number, and then I don't find any issues here. Right, and if you can see that, I can go beyond. But again, it has a limit. You cannot go infinitely large number. Even the long numbers has a limit, and it should not be bug, it should be the big number, right? So it goes, but I see that the long can store much larger number than the simple integral number, both in the positive as well as the negative sense. Now a question for you people, if big numbers like long can store such a huge number, why not always use long as a data type? Why do you use int? The reason for that is, you should always make use of the long only when you know already that you have to actually go and store a very large number. In the case, if your use case is only to store a small number and you make the data type as long, now it will not give you an error. But as soon as you define a variable with a data type long, it's going to reserve that much of space in the memory. It's going to reserve that much of space so that in the future, if it has to go and store, it will go and store data into that. So it leads to the unnecessary wastage of the memory, and that's how we should try to avoid it. So we should try to decide what kind of data I have in the hand, and based on that we should go and decide what should be data type. So two numeric data type that we have already seen, one is the int, another is the long. Let's try to think about the third one. Let's say that I have a requirement of storing data which is much smaller than what integer range provides. For that we have another data type called as the short data type, short, and then I go and say that short number, and here I can go and type 1, 2, 3, it's all fine. If we keep on increasing, it's all fine. If we keep on increasing, all fine. If we increase further, it has started giving me the error. So even the sort has the limit after which I have to go and store data. So in the case, if I have a very small data and I know that it doesn't require the range what the integer or the long provides, I can just go with the sort data type itself. In the case of the extremely small data, let's say that I want to have a data which is less than 3 digits. Typically, I can use another data type called as the byte, which I can go and say that byte number, and I can say that 1, 2, 3. Till 1, 2, 3 it is fine, but as soon as I go and put 0, this will give me an error, right? So we have understood there are 4 different types of the numeric data: integer, long, short, and byte, and all of them are the integrals, right? There are two more types of numerical data, which is called as the float and the decimal numbers, right? So float and the double. Typically, in order to deal with the decimal numbers, we make use of the float and the double. Let's try to see that. So now if I go and talk about the decimal numbers, to represent decimal numbers, we have two representations, sir, right? So one of the representation is called as a float, right? So if I go and have to represent a float number, let me go up, I go and say that float, and I go and say that num1 equals to 123.4. And I go and enter, right? So this is 1, and then I have to go and prefix suffix with the f to represent as a float number, and then I can go and say that double num2 equals to again 123.4, and I go and enter like this. Now why it is giving, because num2 is already defined, so let me go and define another number called as num3 here. Now both float is also being used to represent a decimal number. The double is also being used to represent the decimal number. One of the very common question asked in the interview is that both float and the double is representing a decimal number. How is those different? So sir, float and double differs mostly in two aspects. The first aspect of the difference is that float normally is used to store a smaller decimal number, right? So it can store up to the 4 bytes. On the other hand, the double data type numbers can go and store the data up to the 8 bytes. That's number one. And the second difference is that the data type which is float have a lower precision, right? So for example, a float number has a precision limit of up to 7 decimal digits. This is the precision level. Whereas if it is a number of data type double, it has a precision limit of up to 15 to 16 decimal digits. Now let's try to understand that what is the meaning of this precision and what could be better than using with the help of an example itself. So let's try to see with the help of an example. Let's say that I go and define a big float number, right? So I go and call it as float, and I go and call it as fnum, and I go and call it the big number 1 2 3 4 5 6 7 8 9. 0.1 2 3 4 5 6 7 8 9, and I go and call it f. It's a big float number, fair enough, cool. And then I go and define another number called as double, and I go and call it dnum, and the same as 1 2 3 4 5 6 7 8 9 dot 1 2 3 4 5 6 5 6 7 8 9, right? So I have defined two big numbers, one using the fnum and another is the dnum. Right? And I'm saying that this number has to be stored in a variable called fnum, which is of type the float, and it has a precision limit of only say like 7 digits. Right? So this is the precision up to the 7 digits, and this, because it is a double, it will have a precision digit up to the 15 to 16 digits. Now let's try to run this and see how fnum has interpreted these numbers and how dnum has interpreted this number. So I go and say that sys out, right, and I go and put here as fnum, and similarly I go and that sys out, and I'm going to put the dnum here, and let's try to run this and print. So when I go and run this, if you see here, when the fnum is getting printed, boss, right, I'm coming till 1 and it is only going till 1 2 3 4 5 6 7, and this is the 8th one, right? So it only goes till this point, and all the other point has been approximated as 9, right? This 8 9 dot 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 has been approximated as 9. Whereas when I go and talk about the double number, it is going till 1 2 3 4 5 6 7 8 9, 1 2 3 4 5 6 7, till here it is coming, and then this has been approximated. So when I go and make use of the double and I'm dealing with the decimal numbers, I will do the better precision. So in the highly statistical calculation, when you have to deal with the big decimal numbers, and you know that even if you do some kind of approximation, it might compromise your results, experimental results, you know that you have to go and make use of double, but that will come at a cost of a higher space. Like this, there are many other data types in Java. If you would like to go and talk about the other data types, what we can do is, in details, we can go to the Java documentation, right? So let me go and open the, I can go and search the Java documentation data types. When you go and hit this, let me go and click on this Oracle Help Center, and you will see that these are the different data types that we have. Let me go and zoom up. Right, the different data types like byte, short, int, long, float, double. We didn't talk about the boolean. The boolean is another data type which is either true and false, and then there is a char and the string. Let me go and take the examples of boolean and the char string as well. So if I talk about another data type, it could be, say for example, char, and I go and say that char flag equals to a. So the char is another data type which is represented by the single inverted commas, as we see here. I have come the single comma here, right? And there's another data type called as boolean, which can only have the two values, boolean, and let's say that is true, and I can go and say that, okay, it could be true, it could be true, or it could be false. So boolean is something which can be either true or it could be false. So all these data types, if you want to go in detail, you can come to this page and talk about each of these data types: byte, short, int, long, float, double, boolean, and char. Now since we have understood this, there's another concept called as the default values. What is the meaning of the default value? Let's try to see that. As you can see on the documentation itself, each of these data types, if you don't go and assign any value, the byte has a default data type of 0, short has a data type of 0, int has a data type of 0, long has a data type of 0, float, double, everything has a data type of 0, character is this character, string has a null, boolean value has the false. So these are the default values. So finally we have come to the end of this session. In this video we have talked about was that what is variable, right? What are the different data types? We saw each of them with a good example. Let me know in the comments if you are enjoying this journey and how you are liking these sessions. Keep me posted and come back.